In this video I will try to repair this board. It's for controlling the motor of a sliding gate. It was repaired before me. We have here, they shorted the triac. It was cleaned by a product that contains some oil, so some of the button didn't work no more. This is for the menu, and for the selection it didn't work properly. Maybe the relay have problems also. I will replace the 4 buttons with those, and we will see. So we will try to remove those buttons. I replaced the 4 buttons. They are function now. When we press the button, we obtain error 8. This is normally because we have a tamper switch for the door that access the manual mode. I will remove the bridge here and test the triac. We will test if there is a short circuit. Oh, this is we have here 58 ohm, 69 ohm between the stop in. We can compare with the other circuit, other board. This board has the processor we have the same value, 66. This is maybe normal. This processor is burned with this memory, although this memory has a burn here, maybe with high voltage. So I will test the board. I will send the opening command here. I will power the board first. Now it's in the opening phase. We will hit the open switch for the gate. Here we have the timing. After 13 seconds it will close. Here in the closing position, I will close the limit switch. I will test the relay. I soldered the wire here for the power supply. I will test those relays. We have the connection of the motor, 3 wire. Those 3 pins here. So we will test this relay. And this one and this one. Now all the relay, we have those 2 wires connected. Now we will open the gate after powering power supply. We will test which relay is closed now. We will test the power delivered to the relay. 1.4 volt. It may need 2 power supply because we have 3 wire coming from the transformer. So if we see here, we have three wire coming from the transformer, ground, and 12 and 24 volt alternative current. So we must 2 power supply in order to test this board. I will grab the other power supply and we'll do the test. The owner bring me the motor. We'll put the board to do some tests. So we have the limit switch for closing and opening the gate. This is the gear. This is the capacitor. This is the encoder to count the number of rotation and to adjust the speed. Now we will put the card. So this cable of the limit switch must be connected here. This is for the encoder. This is for the transformer, and this is for the motor. Now the board is in its place. I will apply the power and do a test. So we have the remote control. We have the relay, the sound of the relay, but the motor didn't. Maybe a problem of the relay or of the Tiriac. I will test those relays. They are controlled by the circuit. It's ULN 2803. We have here the positive in common. We must apply 12 volt between those points. We have here the coil of the relay, and inside the circuit we have the protection diode. And here we have the transistor, Darlington transistor. It functions open collector. So we must apply here the positive, not here, in order not to damage this diode. I will solder a wire here in the common rail. We will use the power supply. So we hear the sound of the relay, of each relay, and here we must bring the meter and we can test the continuity. So we have here, this is the opening, normally closed, and we must test here. Every relay has the two contact. This relay is okay. Now we see the other relay, this one. It's okay. We see I test the other contact. Oh, we have it's okay. Now we will test this one. Luckily the power supply has a limit current. Okay. Let's test all the relays. Okay, this one. Okay. So the relay is in, those relays are in good condition. These were tested. So all the relays are okay. I will power the board and I will see if we have a 12 volt between the stop point. So I flipped the board. Here we have the transformer for the power supply. This meter is only to detect if we have a high voltage, 240, because when we forget this, we can touch the high side. This is the hot side and we have the cold side. This board mixed with OLED power supply with transformer and diode and the modern switching circuit. We have both circuit here. We have here 12 volt and 24 volt AC. This is for the photo cell and other security component. We can test here the output. Here we have the 15 volt. This one power the relays, and here we have 5 volt. This 5 volt to power the microcontroller and the EPROM. Here we have the two ULN 2803. This one controls the relays, and this one maybe it controls the LCD. We have MOC optocoupler to control the triac here. The problem here is with the voltage. When we hit the button, now the voltage is in 15. Here we have the voltage 15 volt. It dropped to 2.6 volt. But here we have still the 15 volt here. So the problem is with the ULN. Here we have the 15 volt output. but here the voltage didn't drop. Here we are in the timing waiting phase. When the relay close, the voltage dropped to 2.6 volt. I will see the voltage here for the other circuit, maybe here. We have 5 volt. This ULN function with 5 volt to drive the LCD, but this one with 15 volt to drive the relays. I will remove the power supply and we will see. After some research, I found that the plus VDD here is not connected to the 15 volt rail. This pin is connected to the positive rail of these 4 relays. Here, and otherwise with this board, we have a connection. This board has the CPE burned. But here we found that we have only some sort of junction. We measure here, we found 0.8 volt. And here we found the direct connection. So I will shunt this 15 volt directly to this circuit and we will do the test. So I will connect the positive 15 volt. So we will connect 15 volt to the relays. We will test if there is a connection with the ground. So here we have the ground. We have a connection. Now we will do the test. We have here. We will plug the radio module, the receiver. We will Here we have the 220 volt. We will see if the 15 volt drop or no. This is the ground. We will test here. Here we have 15 volt. This is the power supply. And here we have the power supply at the pin of the ULN 2803. We have 15 volt. Now we will press the button and we have 15 volt fixed. We haven't a drop of voltage. So now I will assemble the board with the motor and we will test if the motor turns. The problem was a bad connection between plus VCC and the 4 relays here. They are switched by this circuit ULN 2803. I connected this point here with the positive relay. We see here 15 volt is common rail for those relays, and the circuit has some transistor which function as an open collector, which connect the other side of the coil with the ground. Now we can see that when we action the remote, the motor turns. Now after 30 seconds it will close automatically. This triac is to adjust the power. It is controlled by this opto triac. Now in the closing phase, we action this contact to stop the motor. Thanks for watching, and for the next video.